Good morning, everyone. The internet has the remarkable ability to connect people, but establishing trust in online interactions requires the right tools and information. And this is where Trustpilot comes in. Founded in 2007, with a vision to create an independent currency of trust, Trustpilot needed to handle the increased traffic volume as demand grew. My name is Gunnar Grosh. I'm a developer advocate at AWS.
And I'm A.Timofte, Director of Engineering at Trustpilot.
And in this session, we want to explore how Trustpilot utilized event-driven architecture on AWS to scale while maintaining a high level of trust and transparency. And the overview is going to provide insight into Trustpilot's journey to build a secure and reliable platform that has earned the trust of millions of consumers and businesses worldwide. But we also want to give you insights into what event-driven architectures are and the benefits of using it. So let's get to it.
Awesome. Thank you, Gunnar. So before I go into my presentation, I want to say a few things about my morning, which started with the blue screen. And you also see me from the side because my central camera doesn't work. So this happens. We're all engineers here, so we know testing and staging is not the same as testing in production, but it's working. So let's get to it. I'm here today to talk about the single word. It can be hard-earned, but has the power to shape our relationships and fuel business growth by increasing consumers' confidence. That word is trust. At Trustpilot, we enable people to read and write reviews and to find companies they can trust. Because reviews help people like you and me to have more confidence in what we buy. They are also an opportunity for businesses to learn and improve from the feedback they receive. Trustpilot is an open and transparent service that brings both sides of the community closer together. We help ignite trust within this community, and we are on a mission to be the most recognized symbol of trust on the internet. Since 2007, we've grown to house over 210 million reviews. However, the growth hasn't been linear. In 2021 alone, we received over 47 million reviews, which was a 21% increase compared to the previous year. And the number of reviews is constantly increasing, while their importance is becoming even more critical. With the large volume of reviews, our service must be trustworthy for us to succeed. And to scale trust, we need to have both reliability and integrity. However, scaling trust is no mean feat. Today, we are in a strong position, but our journey hasn't been without effort. If we look at where we started, our platform was built on a monolith and on-prem databases. Given that this was many, many years ago when microservices were not the most popular topic, and the fact that the company was at the beginning of its journey, it should not shock anyone that that was the case. In fact, our experience started well, but we soon found we were unable to handle our growth. Hiring more people wasn't the answer. It meant planning, alignment, and having to revert changes due to bugs were all a headache. And more usage caused more reliability issues, resulting in product outages. Not the best experience for our consumers. Now, I still remember TRUSTPILOT'S Christmas parties in the early days, where all of us developers were prepared to go back and work. Because it became a tradition that some outage would happen. And of course, what better way to stabilize our platform than after a few cocktails? We knew we needed to make a change. So we transitioned to an event-driven architecture. But how does that work? For that, I will pass it over to Gunnar, who can tell us more about event-driven architecture. Gunnar?
Thank you, Angela. So from weather station data to cars to IoT devices, everything around us is emitting events. The world is event-driven. So I want to walk us through what event-driven architectures mean and how they work, and give a good example of how we at AWS and Amazon are using event-driven architectures today. So event-driven architectures, they lead to loosely coupled systems. Events are the basis and the glue that allows these systems to work together. It also gives us an increased agility, and it helps us build more scalable and reliable applications. And these are the basic components of an event-driven architecture, where we have some sort of event and we have our event producers who then passes on an event record into our event broker. And then finally, we have our different event consumers, the consumers of the event that happened previously in our architecture. And we have different patterns within event-driven architectures, and these patterns meet different requirements. For instance, point-to-point messaging, where we have queues as the event broker, or publish-subscribe messaging, where producers send the same message to one or many consumers. Or perhaps event streaming, where we have a continuous flow of events, where consumers then poll for new events or can replay existing or previous events. And this is a very simple architecture that shows an e-commerce application. And in this example, we've only implemented a few APIs. In this system, you couldn't even return a product, but it decouples the create account, the create order, and the list order APIs from the service using an event bus. And if we look at an architecture, we have collaboration between our events. And we can see in this system where we have our shopping cart, our order service, shipping service, and so on, that all events flow through our event bus. And in this one, we could easily add new parts to it. For instance, an email notification service. So event-driven architectures, they are evolvable, where we can easily add on new features within our architectures. And some of you might be familiar with Gall's law, and that states that all complex systems that work, they evolved from a simpler system that worked. So if you want to build a complex system that works, well, start off by building a simpler system first, and then over time, you can then improve it. And with event-driven architectures, you can start with a very simple system and then incrementally build a more complex solution. without really any changes to the existing components. And I like the comparison to our 2 pizza teams at Amazon and AWS. Smaller teams that are focused on individual microservices or components that then work together to form the whole system. So evolvable architectures, the ones that we get with the help of event-driven architectures, they help us innovate, and they help us innovate rapidly. And innovation, as we know, that's part of evolvement. And a spider is the most central thing in a web. And in our web, in the event-driven architecture web, that spider is the event bus, the most important thing within an event-driven architecture. And for us, well, our spider in this case is Amazon Event Bridge, our serverless event bus that allows you to receive, filter, transform, route, and deliver different events. And the producers in this case, it could be different AWS services, it could be your own applications creating and then sending events, or it could be any type of SaaS solution, for instance. And it's, of course, evolving in the same way as we mentioned around event-driven architectures. So it's adding new features for users, adding archival, adding schemas, adding Event Bridge Scheduler to allow you to schedule millions of events. Events, they are also composable. So you can combine parts of the system together to achieve a lot more. And the whole is, of course, greater than the sum of its parts. And the success of Unix, well, it was the power of composing small components with unified interfaces. And many of us know about Unix pipes, components with standard interfaces that allows you to compose larger systems from smaller ones. And in AWS, there hasn't really been a uniform way to compose events. And if you've done it, well, it's been an all or nothing approach, and it requires the developers to write glue code. So could you use the pipes principle with AWS services? Well, we recently launched a new feature for Amazon Event Bridge called Pipes. And this is a new feature that is then designed to integrate messages from many different AWS services. And it eliminates that need to write glue code to connect services together. So you can do simple transformation built into pipes or more complex transformation with the help of other services. And talking about event-driven architectures, they also enable global scale. So companies that build multi-region, high-performance system, many of them use event-driven architectures. And we at Amazon, we use event-driven architecture in some of our largest systems. So I want to show you that by talking about one of our AWS services. So DynamoDB is built for single-digit millisecond performance and a global scale. And it regularly scales to a massive 10 trillion requests per day. And there are many things we can learn by taking a look under the hood of DynamoDB. In this case, I want to show you what it looks like with the global tables feature. So imagine you're building a video application with global users. You might then need global tables. And global tables provides you with a fully managed, multi-region, multi-active database. It's fast, it's local, it has read and write performance for massively scaled global applications. And active-active architectures, meaning all regions are actively serving traffic simultaneously. Conflicts due to concurrency issues are resolved using last writer as determined by the service. And for better conflict resolution, the service also uses a global clock and virtual clock. So if you were to build this replication system, there are a couple of ways you could approach it. You could do it synchronously. So every put item would have high latency as you wrote to all regions as one. And that also means that if a region is unreachable, you have complexity. It would be a two-phase commit. Asynchronous is how global table replication actually works. So updates are propagated to other regions using existing DynamoDB streams. And there's no cross-region latency as the put item doesn't have to wait for replication. And DynamoDB Global Table Replication Engine is, of course, built using event-driven architecture. As you, as a customer, then write to a DynamoDB table, we have a system that listens to the DynamoDB stream for that table. And the DynamoDB stream, well, that's an ordered flow of information about any changes to items within a DynamoDB table, events. And the stream captures information about every modification to data items in this table. The core component is what we call the replicator. It's responsible for reading messages from an SQS queue and then processing these tasks. And all replicators that can handle new work, they pull from this SQS queue. And we have thousands of replicators that are coordinated using this SQS queue. And if you have a number of global replicas, well, there will also be a number -1 DynamoDB stream readers. And replication happens independently to each destination. So a failure to replicate to one region doesn't impact any other regions. And DynamoDB Global Tables, well, it makes use of a few different patterns, event-driven architecture patterns. So for change data capture, a pattern of reading a database stream of events. Asynchronous coupling, where partial progress even when some components are unavailable. And it uses self-healing replicators. So if a replicator fails, new replicators pick up the work. And with this primer to event-driven architectures and an example of how we're using it at AWS, I want to go back to Angela and the TrustPilot story.
Thank you, Gunnar. Now, reviews are obviously at the core of TrustPilot. But now, meet Sylvia, who had a great experience with the flower shop and wants to share it by writing a review on TrustPilot. When Sylvia submits her review, behind the scenes, an event is published to an Amazon SMS topic. The submitted review topic has over 20 subscribers, with each one of them completing different asynchronous processes using Amazon Lambda function, Amazon ECS, and other Amazon services. One of those processes is to publish the review after it has passed our compliance checks, which is another event sent to an Amazon SMS topic that will fan out for Amazon SQS to consume and trigger other processes, with one of them being storing the data. Choosing the right data store has been a challenge in itself, as the number of reviews being read daily increased from thousands to millions. We had to find a scalable, flexible, and cost-effective database. After many iterations and trials, Amazon DynamoDB stood out as the right candidate and is now the most used database at TrustPilot. We all know that we can plan for expected increases in traffic, such as periods including Black Friday and Cyber Monday, even when using a monolithic architecture. But our latest event-driven architecture and the use of Amazon DynamoDB provides us with increased flexibility, meaning both expected and unexpected traffic increases can be easily dealt with. One of those unexpected events more recently was COVID-19. During this period, everyone was forced to buy online. We all needed to know who to trust. As a result, searching and reviewing on TRUSTPILOT became more important than ever. This increased our traffic more than we could have ever predicted. Thanks to the cloud elasticity and the adoption of an event-driven architecture, our platform is able to scale to expected and unexpected traffic increases, while our teams can continue focusing on product releases and innovation. Dealing with the growth and scale of reviews on TRUSTPILOT is one challenge, but maintaining authentic, useful, and trustworthy information is quite another. At TRUSTPILOT, our primary goal is to provide users with a reliable and trustworthy source of information. We recognize the importance of our role in facilitating fair and honest reviews, and we take this responsibility very seriously. To ensure the credibility of our reviews, we've made significant investments in enhancing our fraud detection systems. These systems have been designed to effectively identify and remove fraudulent or fake reviews promptly, helping us in keeping the integrity of our platform. But let's go back to Sylvia's review. As TRUSTPILOT is built upon an event-driven architecture, the loose coupling of systems means that we are in a position to easily integrate and evolve our existing architecture. As an example, subscribing to the review submitted topic and using Amazon Kinesis for real-time ingestion, we send data to our compliance and fraud detection models. While by using Amazon Step Function, we orchestrate workflows to take action on abusive behavior or unusual patterns in reviews, to name a few. Combating fraud and deception in online reviews is a complex challenge. However, it is our primary goal. And for that reason, we ensure our technology is able to scan 100% of reviews coming through. With the right mix of technology, community help, and expertise, in 2021, we prevented and minimized the impact of misleading information and removed 2.7 million fake reviews. This is the equivalent of 5.8% of the total reviews written in 2021. That shows us that the majority of businesses and consumers use the TRUSTPILOT platform constructively and in the way it was intended. However, sadly, there is that minority who use the platform in a way that doesn't meet our guidelines and wish to undermine our community. And for that reason, we remain vigilant. We believe that to build trust, you need transparency. And for that, all businesses on Trustpilot have a transparency page showing our community exactly how they engage with reviews on Trustpilot. We know consumers are looking for brands that they can trust, and they're increasingly turning to online reviews to help them make informed purchasing decisions. Equally important, trust is a fundamental component of any successful business. And in today's competitive market, it's what can help businesses stand out. With over 580 million business profile views and over 210 million reviews, we're constantly looking for insights that we can offer businesses to improve their products and services and build trust with their consumers. We understand that businesses are facing unprecedented challenges right now. But we've seen that those who have stepped forward to help their customers have been rewarded with increased loyalty and positive feedback. Trustpilot is committed to helping businesses navigate these difficult times and emerge stronger on the other side. In fact, in December 2022, we have published a report that explores the changes in UK consumers' sentiment and business behavior during the cost of living crisis. This provides a range of recommendations for how some of the industry trends can be addressed and how trust in businesses can be improved. Catering to both consumers and businesses while being trustworthy and reliable without compromising on integrity, it's not easy. And to get to where we are today, it's been a journey. Our architecture has grown and evolved to make sure we serve our users and help them earn trust in one another. We must continue to adapt and innovate to stay ahead and meet emerging challenges. Now, although Amazon SNS has been a rock-solid core service for us, we are excited by features of Amazon Event Bridge, including its schema registry and ability to reply event streams. Amazon Event Bridge Pipes, one of the latest releases introduced at AWS reInvent, brings features that can help us spend less time on integration code and more time on business outcomes. Having an architecture that can scale, adapt, and react to new events is exactly what we need to meet business requirements, protect the integrity of our platform, as well as increase team productivity. We live in uncertain and rapidly changing times. We all need to spend wisely. This makes Trustpilot even more relevant as we help people make better and more trusted decisions about who and what they buy. We won't stop here. We'll continue to invest in bringing more features to help.
Thank you, Angela. So I want to summarize some of the key elements around event-driven architectures. And the first is that event-driven architectures lead to loosely coupled systems. So with events being the basis and the glue that allow these systems to work together, but with an increased agility, and it allows us to build more scalable and reliable applications. But also that event-driven architectures, they enable global scale. So you can build multi-region, high-performance systems using event-driven architectures. And like I mentioned and gave an example of, we at AWS, we use event-driven architectures in some of our largest systems. But perhaps most important, that event-driven architectures help development teams move faster, be agile, and be able to deliver new features easily and without compromising on existing parts of your solution. And with that, we want to thank you for listening in on this session where we've explored how Trustpilot utilized event-driven architectures on AWS to scale while maintaining a high level of trust and transparency.
All right, Angela and Gunnar, thank you so much. That was a very, very, very inspiring talk that you just gave us. We have a couple of questions here from the chat. I would like to point out, this is from Klaus. What kind of event broker would you suggest if it comes to robustness, e.g. they are still alive and kicking, even if a complete availability zone is lost?
Well, event broker for robustness. Do you have anything you want to add there, Angela, about how you're using that today? I don't want to make a sales pitch, perhaps, around AWS services.
We could look at a little bit of context. Mm-hmm. So one of the things is like the primary drivers of transitioning to event-driven architecture. So I have a few in my pocket, but I'm kind of, we could have a look at that, and then we could also kind of think about the context of how those events are handled. But would you like to talk a little bit about the primary drivers for event-driven architecture?
Yeah, I think a lot about what both Angela and myself talked about during the session is the drivers for that, having that scalability and being able to evolve your application as it grows. I think that's definitely one of the drivers that we're seeing. Another driver is the fact that all of the applications, they emit events constantly. So whatever we are building, whatever we have today, starting out with the Monolith that Angela mentioned for Trustpilot, they are constantly using and emitting events that then can be used to make that switch to a more event-driven architecture and being able to then easily add new features as the applications.
Okay. I'll add a couple of things, maybe that, so one of the questions was about outages being a driver for event-driven architecture. But it's actually, there's an interesting driver here where, so many companies will say they have automation, and then I'll be like, okay, what kind of orchestration do you have? And orchestration being more event-driven. So one of the key drivers that we see with our customers is keeping things synchronized. Because, so you have an automation and it runs when? Well, I've made 5 changes since the last time you ran your scripts, and that's really nice, but we don't know how those changes are going to work atomically, or, is every event of a commit getting run through all the way to deployment, for example. And then the other one is when you have an outage, there's that guy at 4 a.m. that made a change to somewhere in order to get his changes in, and now he's late for work. Right? So when we have an event-driven architecture, things are synchronized, at the commit, at the pull request level, so that everything that is actually in code is in production, and we know exactly what those kind of changes are. We're going to be looking at some things along this lines with Sidero and Talos a little bit later as well. Another question that we had was, and we had a few answers in the Q&A, but if people want to learn more, where would you like to send them?
So we have a great workshop on event-driven architectures that gives you a good overview of how you can start building fairly small applications using event-driven architectures. But as we talked about with Gall's law, a system that starts out working great as small, you can easily grow that system into a more complex and larger system. So starting out getting hands-on with event-driven architectures, I would say that is a good start for existing developers or architects.
Mm-hmm. So pretty much at any level, you could start experimenting with event-driven architecture already, and then start taking it into use anywhere within your development work or within your team or your enterprise, and then already start to get the scalability benefits. I want to applaud you as well that you managed to cover. You had a really beautiful value stream map there. You covered developer experience and platform engineering. I think it was a really beautiful, and 2 slides a minute is a wonderful pace for a presentation. I think that was already also really fantastic. Anything else that you guys would like to add? I think we covered most of the questions that we had.
Angela?
No, I just want to say thank you for having me here. It was great to come and present about the Trustpilot, how we do things, our values, which are very important to us, and how we put those in practice even when it comes to engineering. Because sometimes when, as engineers, you kind of stay away from everything that the company is all about. But at Trustpilot, we are very much looking at our values and developing with the values in mind. So thank you very much for having me here.
Okay.
Gunnar, Angela, thank you so much. This has been awesome. Hi, we're from Efficode, the proud organizer of the DevOps conference.
Our goal is to uncover cutting-edge talks, emerging ideas, and DevOps trends, providing a global forum for practitioners and decision-makers to learn and grow.
We would love to also explore how we can help you excel in DevOps together. Visit us at efficode.com and enjoy the inspiring talks at the DevOps conference.